In our last lesson, we learned that to prove that two triangles are congruent, we have to show that every pair of corresponding angles are congruent and every pair of corresponding sides are congruent. In this lesson, we're going to start adding in some shortcuts so we don't have to prove 6 things every time to prove that two triangles are congruent. The first shortcut is side, 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 which basically says if we can prove that every side in one triangle is congruent to a side in the other triangle, then we can prove that the two triangles are congruent. For example, this example number 1, we can clearly see that DG is congruent to HK, that FD is congruent to JH, and that FG is congruent to JK. Because all pairs of corresponding sides are congruent, we can say that the two triangles are congruent by SSS, side, side, side. On number 2, we cannot prove that these two triangles are congruent by side, 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 because even though BC is congruent to AD and AC is congruent to AC, AB and CD are not congruent. And then lastly, we can see that these two triangles, QPT and RST, are congruent because all of their corresponding sides are congruent. So if this is our beginning proof, I'm going to make my 2 columns. We always start with our givens. So we know that KL is congruent to NL. We know that KM is congruent to NM. And our goal is to prove that the two triangles are congruent. So from what we did in the last lesson, we would still have to prove that we have one more pair of sides that are congruent, and we would have to prove that all 3 pairs of angles are congruent. But by this new shortcut, side, 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 all we have to do is prove that our last pair of sides are congruent. So what side is missing in the two triangles? So we've got side LM for our triangle on the left and side LM for our triangle on the right. And we can always prove that LM is congruent to LM. Our reason is the reflexive property. So anytime two triangles share a side, you can always say that that pair of sides are congruent by the reflexive property. And so now that we've shown that all 3 pairs of sides are congruent, we can say that the two triangles are congruent. And instead of our reason being definition of congruent triangles, our reason is side, side, side. We proved that all 3, 1, 2, 3, all 3 pairs of sides are congruent. Therefore, the triangles are congruent by side, side, side. So that's one shortcut. We're also going to do 2 more shortcuts. The next shortcut is called SAS, which stands for side, angle, side. In the side, angle, side, in order for side, angle, side to be used, we have to prove that 2 pairs of corresponding sides are congruent and their included angles are congruent. And when I'm talking about included angles, I'm talking about the angle that is formed by the 2 sides that are congruent. So because AB and AC are 2 of the sides that are used to match up with the other triangle, the included angle would be angle A because it's right where those 2 sides meet. So if I had 2 triangles and I said that this side and this side are congruent and this side and this side are congruent, if I showed that this angle is congruent to this angle, that is not SAS because that angle is not the included angle. It's just a random angle. So to use SAS, oh goodness sakes. To use SAS, we would have to show that this angle is congruent to this angle. Those are the included angles. And again, included angle basically means where the 2 sides meet. That's the included angle. All right, so we're going to do some proofs now using side, angle, side. So here's our first proof. Given BC is congruent to DA, so we have one pair of congruent sides, and BC is parallel to AD. So parallel does not mean congruent. In this case, we know that those two sides are congruent. But we do have another pair of sides that we can label in this picture. And that is the shared side. Whenever two triangles share a side, that can be added in our proof. AC is congruent to AC by the reflexive property. I forgot to write my given there for step number 2. There's nothing else that we know in this picture without using the given statements. The only two things you can mark up in a picture without looking at your givens are the reflexive property can always be marked. We can always include the reflexive property. And if we have vertical angles, we can always include that as well. So we use the reflexive property. That's the only thing we can include just by eyeballing the picture. The other steps need to be used using this given statement that BC is parallel to AD. And typically when we have parallel lines, what we're going to be using is the alternate interior angles theorem. Not always, but usually when you have parallel lines, look for the alternate interior angles theorem. In this case, we have two pairs of alternate interior angles. We know that angle CAD, which is right here, is congruent to angle ACB, which is right here, by the alternate interior angles theorem. We also know that angle BAC is congruent to angle ACD by that same theorem. I can write both of those pairs of congruent angles in my proof and give the reason as the alternate interior angles theorem, but the only one I really need are the angles that are included between our two sides, which are the ones I marked in red. Those are the included angles because it's where the two pairs of congruent sides meet. So we know that angle BCA is congruent to angle DAC by alternate interior angles theorem. So now I have 3 things marked as congruent in my picture. I have 3 congruent symbols in my proof, and usually that's enough to use one of our shortcuts. So far we've only learned 2 shortcuts. This is shortcut side, angle, side. So we know that triangle ABC is congruent to triangle CDA by side, angle, side. So make sure in this case, because there's a lot going on in this picture, we know what 2 triangles we're trying to prove are congruent. We're trying to prove that triangle PQT, which is this top triangle, is congruent to triangle RST, which is this bottom triangle. And we have 2 things given. We know that PT and RT are congruent, and we know that QT and ST are congruent. Those are our givens. So already in our proof, we have 2 congruent statements. We need one more to use one of our shortcuts. And our given, there's nothing really to go off of in our given. It doesn't say anything about parallel lines. There's no vocab words. So the only 2 things that we can use other than what's given are if they share a side, we can use the reflexive property. And in this case, the 2 blue triangles that I highlighted there, they do not share a side. Or, I mentioned this earlier, we can use vertical angles. And we do have vertical angles here between those 2 blue triangles. So I know that angle PTQ is congruent to angle RTS by vertical angles theorem. And now I have side, angle, side. Here's my side, my angle, and my other side. Side, angle, side. So I can say that the two triangles are congruent. Triangle PQT is congruent to triangle RST by side, angle, side. Let's try a trickier one. So I've got two given statements. So first we know that D is the midpoint of AC. And we know that BD is perpendicular to AC. So no congruent statements left yet. I have 3 to go, that means, to use one of our shortcuts. So let's start with the midpoint. D is the midpoint. Whenever you see a vocab word, that's going to show up in our reasons as definition of midpoint. So what do I know about midpoints? I know that D is right in the middle of AC, which means that AD is congruent to CD. There is our first congruent statement. Next given statement says that BD is perpendicular to AC. So I've got a vocab word, perpendicular. That means one of our reasons is going to be definition of perpendicular. What do we know about perpendicular lines? We know that they make right angles. So BD and AC make a right angle. So that means angle 1 and angle 2 are right angles. We haven't said that they're congruent yet. Based off of them being perpendicular, we just know that they're right angles. Then we can say that angle 1 and angle 2 are congruent, and our reason there is the right angle congruence theorem. So when you have perpendicular lines, it takes 2 steps to get to your congruent statement. First, we say that they made right angles. Then we can say that those 2 right angles are congruent. So in our proof so far, I have 2 congruent statements. I've already used my given statement, so now let's look at our picture. The other thing that I can mark up is their shared side. BD is congruent to BD. And our reason is the reflexive property. They share a side. That's my third congruent statement. That's enough to say that triangle ABD is congruent to triangle CBD. And our reason is side, angle, side. The right angles are our included angles. So we have side, angle, side. So let's try another one. We know this time we have one given statement that BD bisects ABC. That's our given. And so we have a vocab word that shows up here. We're bisecting an angle. So that means one of our reasons is going to be definition of angle bisector. If you use that definition of bisector, it's just not quite specific enough. We're bisecting an angle. So if we're bisecting an angle, that means we're cutting angle ABC in half. So angle ABC, that's up here where B is. Look at the middle letter, B. That's our vertex. So that means that angle ABD is congruent to angle CBD. That's our first congruent statement. Oh, and I guess we had a second given that I should have included. Whoops. AB and BC are marked as congruent in our picture. So because they're marked in our picture, that's a given. So that's our second congruent statement. We have 2 congruent statements. The third thing, we ran out of given statements to use, so we just have to do it based off of looking at the picture. And based off of the picture, there are only two things you can mark up. If there are vertical angles, you can mark those up, or if they share a side, you can mark it up and call it the reflexive property. In this case, they share a side, so we can mark that up and call that the reflexive property. That is our third congruent statement. So we're ready to say that those two triangles are congruent. So triangle ABD is congruent to triangle CBD. And our reason, again, is SAS. So far, we have two congruent shortcuts we're using. SAS, where the included angles are congruent, or SSS, where all three sides are congruent. Now we're going to add in one more shortcut. This is the only shortcut we're going to do that only requires you to have two congruent statements. It's called the hypotenuse-leg congruence theorem. But in order to use the hypotenuse congruence theorem, the triangles have to be right triangles. If they aren't right triangles and you haven't said that they're right triangles in our proof, then you can't use hypotenuse-leg. So if you have right triangles and you prove that the hypotenuses of those right triangles are congruent, so again, the hypotenuses are what's across from the right angle, and you can prove that one of the other two legs are congruent, then you can use the hypotenuse-leg congruence theorem. I'll show you an example of what that would look like. So in this picture, it doesn't tell us our givens, but it's marked in our picture. So given AC is congruent to BD, and it's also given that angle ABC and angle DCB are right angles. Or you could say that the two triangles are right triangles. That would be okay too. So that's given based off of our picture. So because they're right angles, we can use the hypotenuse-leg theorem. We know that the hypotenuses are congruent already. That's AC and BD. The other leg that we can mark as congruent is leg BC. We're allowed to mark that as congruent because they share that side, that leg, and so we're using the reflexive property. That's enough to say that our two triangles are congruent by the hypotenuse-leg theorem. And when we name our triangles, because it doesn't give us a congruent statement, we have to create our own. It doesn't matter how you name the first triangle, but when you name the second triangle, make sure you're matching up congruent things together. So angle A is congruent to angle D. Angle B is congruent to angle C in the other triangle. And angle C in one triangle is congruent to angle B in the other triangle. All right, one last example. And I just want to show you with this one, sometimes it's helpful when you've got overlapping pictures. Sometimes I like to draw the two triangles separately so I can see them a little bit more clear. You don't have to do this, but it might make things a little helpful for you. So I have a triangle WZY and a triangle XYZ, and we're trying to prove that they are congruent to each other. So we have three given statements. The first one says that WY is congruent to XC. So WY is congruent to XC. And that's a lot easier to mark and when I draw the two triangles separately than in the one where they're overlapping each other. I also know that WZ is perpendicular to ZY. So WZ and ZY are perpendicular, so they make a right angle. I also know that XY is perpendicular to ZY. So where XY and ZY meet, that also makes a right angle. Those are my givens. Now, I marked those right angles, but I haven't actually said that they're right. So that needs to go in my proof. I can't just mark things in my picture. I also have to include it in the proof. So I can say that angle WZY and angle XYZ are right angles. And I can say that because it told us that they're perpendicular. So that's definition of perpendicular. Then, by definition of not definition of right angles. We know because they are right angles, the right angles congruence theorem tells us that those two angles are congruent. You know what? We actually don't even need to say that. I'm going to go ahead and write it because I started to. But I forgot we were going to use hypotenuse leg on this one. So I don't really need to say that those two angles are congruent. I don't need this step in this case. It's not a wrong step. I'm not going to count off if you include that step. It's not bad to have extra steps in your proof as long as they're true. We just don't need that step. We just needed to know that they were right angles because that means we have right triangles, which means we can use the hypotenuse leg theorem. So far, we know that the hypotenuses are congruent. We've already used our given statements to say that we have right angles. We still need one more thing. If we're going to use hypotenuse leg, we still need to prove that one of the pairs of legs are congruent. So if we look at our original picture, we can see that these triangles overlap, but they share side ZY. So because that's a shared side, we can mark that up as the reflexive property. So now we have shown that we have two pairs of sides that are congruent. Two pairs of corresponding sides that are congruent. We have a hypotenuse and a leg. So by hypotenuse leg, we can say that triangle WYZ is congruent to triangle XZY. All right, so quick recap. We have 3 congruence shortcuts that we're doing in this video. Side, 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 if you can prove that every side in one triangle is congruent to a side in the other. If all pairs of corresponding sides are congruent, you can prove that the triangles are congruent by side, side, side. We have side angle side, which says that if you can prove 2 pairs of corresponding sides are congruent and their included angle only, is congruent, you can use side angle side. So for example, on this particular example, we would not have been able to use side angle side for this proof that we just did because the angles that we showed are congruent is not the included angle. The right angle is not included between the 2 pairs of sides that we know. So we could not have used side angle side on this one. We could, though, use hypotenuse leg on this one because they were right triangles. So that's what we did. So those are our 3 congruent shortcuts. And then keep in mind the only things that you can mark as congruent other than what's given to you are if we have reflexive property or vertical angles. Otherwise, you have to use your given statements to come up with more congruent statements.